Welcome everyone to this course with the name Spring Framework. Guys, before we head on talking about different modules of Spring Framework like Spring Core, Spring AOP, JDBC, MVC, REST, SOAP, security, this, that, blah, 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 let me first make you understand why Spring Framework itself. What's so special and unique about this framework that everyone in the computer science industry wants to make use of this framework while coming up with any web application or a non-web application? Let's try to figure out the answer to this question with the help of a very simple story. Let's say I'm the project manager of a team of size 3. So 3 brilliant developers are working in my team, Ajit, Sandeep and Geeta. And I'm supposed to be delivering a project with the name Restaurant Management System. Now, to come up with this restaurant management system, all I want from my team members is to write these 3 classes for me: test class, restaurant class and T class. As you can see, these are very simple classes what I want my team members to write for me. So I distributed the overall project in such a way that all of my team members would get to work on a single class for me. Ajit is supposed to be writing test class for me. Sandeep is supposed to be writing restaurant for me. And Geeta is supposed to be writing T class for me. I asked for the timelines to my team members, and that's what they have given to me. Ajit said he's going to take around 10 days to finish up writing test class. Sandeep would take 10 days to finish up restaurant class, and Geeta would take 15 odd days to come up with T class. Now, I don't have any problem with this, whatever timelines my team members have given to me to come up with these 3 classes. But still, I would like you to concentrate on a very big problem which I can observe. And the problem is my team members here in this kind of a project cannot work in parallel. They have to work in a sequential manner. So the whole idea is, if you look at what Ajit has to develop for me, this test class, Ajit would need to make a call to preparatory function of restaurant object. So for that, Ajit first needs to create the restaurant object, and once he is able to create the restaurant object, then only he can use the reference of that object to make a call to one of its function preparatory, this one. So Ajit basically has to write a class which depends on another class. So unless and until that class has been provided to him, Ajit actually cannot start writing his own class, which is test class. So here, looking at this kind of a requirement, restaurant class has to be given to Ajit first, and once that class has been provided to him, it's only then he can start writing the test class. I hope the problem is clear to you. So he has to wait for Sandeep's work to be finished up first. So means he has to wait for 10 days till the point Sandeep is going to finish up writing restaurant class. Now, same is what Sandeep is facing, same kind of a problem. Sandeep has to write the restaurant class, which has to make a call to preparatory function of T object, this one. And for that, he actually has to create the T object first, the way I've shown you here. Now, first he needs to create the T object, then using that object's reference, he can actually make a call to one of its function, preparatory, this one. So the whole idea is Sandeep actually cannot start writing restaurant class unless and until T class has been provided to him. So that's the kind of a problem that I want you to observe here. So Sandeep needs to wait till the time Geeta is going to give T class to him. So Sandeep needs to wait for 15 days, till the point Geeta would actually come up with T class and provide that to Sandeep. So overall, my team members get to work on these classes, but they cannot work, parallelly. First, Geeta needs to spend 15 days, then Sandeep needs to spend 10 days, and then Ajit needs to spend 10 days, and then overall 35 days is what overall my team members are going to consume to come up with these 3 classes. Now that sounds like a big problem, guys. Why can't my team members work in parallel to each other? Why Ajit needs to wait till the point restaurant class has been provided to him? Why Sandeep needs to wait till the time T class has been provided to him? Why can't Sandeep just start writing without waiting for T class to be given to him? Why can't Ajit start writing test class without being provided with a restaurant class? If I could make my team members do their job without depending on others' work, then definitely this time I can reduce drastically. So here, if 15 days Geeta would take, 10 days Sandeep would take, and 10 days Ajit would take. So overall, if my team members are working parallelly, then at the max 15 days is what my team would take to come up with these 3 classes. But this, guys, seems like an unachievable task. How Ajit can write a test class without creating the restaurant object? How Sandeep can write a restaurant class without creating the T class? Because to create T class, Sandeep needs T. To create restaurant object inside test class, Ajit needs restaurant class to be provided to him. Well, I've here described the problem with the help of only 3 classes. Just imagine this scenario, real-time scenario, when you got to work on a project which is so big that hundreds of developers are working on it. They are supposed to be delivering thousands of classes there. Now, if one class depends on another class depends on some other class, how much worse that situation might look like. That is the thing that you have to observe. That is the thing that you have to understand. A development cost is going to increase. That's going to cost huge in terms of time and money to the company which is actually funding that project. So here, if you are facing such a kind of problem in your real-time project, then your decision is right, guys. You have decided to learn Spring Framework, and I respect that decision because Spring Framework is what is going to solve this problem. Spring Framework would actually help your team members to work in parallel to each other without waiting for others' work to be finished up first. So if you have decided to use Spring Framework or any other framework which works on the same principles on which Spring Framework works, then actually this is achievable. I can make my team members work in parallel. How I would use Spring Framework to make my team members work in parallel without waiting for others' work to be done? That's what you have to understand today in this session. So what I would do, this is how I would organize the rest of this session. I would solve Sandeep's problem first, and whatever solution using Spring Framework I'm going to provide to solve Sandeep's problem, same solution using Spring Framework you have to apply for test class, and that's how overall we would be able to solve this project's problem. So let's start with solving Sandeep's problem with the help of Spring Framework. Are you all up for this, guys? Thank you very much. Let's try to solve it. So here we have the restaurant class. Now I want Sandeep to develop restaurant class in such a way that he should not be making use of T word inside it. But still, he should be able to write this without seeing the compilation error. How? That's a question, right? How Sandeep could actually, write this piece of code without creating T object this way, without using new keyword. So that's a culprit, guys, new keyword. Whenever you create an object by making use of new keyword, that actually creates the problem which I described over here. So many computer scientists who actually are pioneer in the field of object-oriented programming concepts, they feel like when you use new keyword in Java to create an object, that's kind of a blunder. You must not commit that. You must not do that. You must not make use of new keyword inside your Java classes. That's what most of the computer scientists in the field of object-oriented programming feels like. So if I would make Sandeep not to make use of new keyword, then definitely this line Sandeep can ignore writing. But thing is, if Sandeep would not write this line, then how this rest of the piece would work? Definitely when Sandeep would write this, Sandeep would face compilation error first. Now what is this T? What is this? Is this T class reference or it's something else? Well, what is it? So it's going to give compilation error, right? But yes, if I could omit this line from here, then actually Sandeep's class is independent of T class. See, can you find anywhere T written anywhere? That T class? Nowhere T word is present. It means Sandeep can actually start writing on the restaurant class from the day one when I distributed the tasks to my team members. But thing is, this is not going to work. So here, definitely Sandeep cannot ignore this line. Definitely Sandeep needs T object to make this work at runtime. But at the same time, I want Sandeep not to make use of this T word. So how that is achievable? That's something you have to understand. Because here, if I have to solve this problem, we got to break this problem into two halves. So this line is the culprit, isn't it? I want Sandeep to do something for this line so that he should be able to work on the restaurant class independently. So here I can see that T class has been specified, here at the left hand side and here at the right hand side. So here we got to solve this left hand side problem, and then we have to solve the right hand side problem. What I mean by solving right hand side and left hand side problem, I just mean that we first got to take out this T word from the right hand side, and once we are able to solve this, means we are able to take out this T word from the right hand side, then we have to do something in the left hand side so as to take this T word out from restaurant class. If I could do so, if I could guide Sandeep to achieve this, then he can work on restaurant class independently. Now let's try to first solve this right hand side problem, and then we are going to talk fully about left hand side problem, solution for left hand side. We have to take out this T. How to do so? Well, that is something can be achieved using Spring Framework. So Spring Framework says, hey developers, whenever you are writing a class, wherever you have to create an object, then don't create that object with the help of new keyword. Never do so. Instead of that, what you should do, what Spring Framework suggests to the developers, it suggests that you simply do not create object yourself. So you completely omit the piece of code that you have written, new T or whatever. So here I have omitted this line on the recommendation of Spring Framework. But then what? If I have omitted this, even then this piece of code is not going to work, isn't it, guys? So here this T reference is not having any object, right? This is not pointing to the T object because I just omitted that new T from here. So whenever you are going to run this project at runtime, it's going to give you null pointer exception here. Yeah, T.preparative, it will cry that, hey, this T reference is actually not having any object T. So I'm throwing null pointer exception here. So how Spring Framework you are going to use so that the application would not throw null pointer exception, and here magically something should happen and this T reference should have the T object. How is that possible? And that's what Spring Framework is used for. So what Spring Framework says, hey guys, if you have decided to use me, then I would provide you with an XML file. So whatever XML file I'm going to provide to you, you simply got to specify the class name, what you are writing. So here, what Sandeep is going to write? Restaurant class, right? So on Spring Framework's recommendation, you have to, Sandeep needs to specify this class name over there inside that XML. And inside that, class name, Sandeep also needs to specify the name of the class whose object Sandeep actually wanted to create inside restaurant. So here, Sandeep actually wanted to create the T object using new keyword, and on the recommendation of Spring Framework, actually Sandeep would omit that from the right hand side. Now whatever he has omitted, same is what he has to specify here in the XML file. So here he would specify T. So in other words, what Sandeep is telling to Spring Framework by specifying this information in the XML, Sandeep is simply conveying, hey Spring Framework, when at runtime, someone would create the object of restaurant and then would make a call to prepare T function of it. And whenever that function is being called, inside that, whenever t.prepare T is being executed, that time automatically this T reference should be assigned with whatever you have specified here inside restaurant. So T you have specified. So Spring Framework is supposed to create the object of T automatically for you, and automatically Spring Framework needs to assign that object to this T reference so that at runtime this would not throw null pointer exception. So here, see, using Spring Framework, actually you have solved the right hand side problem. So we have here omitted this right hand side, and still with the help of Spring Framework, we have made Spring Framework to indirectly create the T object and assign the same to T reference here, so that at runtime this would not throw null pointer exception and this would execute normally. So using Spring Framework, we have actually solved right hand side problem, guys. Now, after solving this right hand side problem, still the problem exists, guys. T word is still present at the left hand side. So we have here taken out this right hand side. So here there is no code over here. So it's something we have omitted, and that information we have kept in the XML file. So it's going to help us getting the T object and assign the same to this T reference automatically. You don't need to do anything for it. But here, what to do with this T word, what still is present in the restaurant class? Well, this problem we have to solve. This left hand side also we have to solve so that T word would not show up here. And this we would solve with the help of a concept that we learned in those early school days, guys, when you learned Java programming language. You remember you learned the concept of interface. Now, don't tell me that you haven't learned that. I know you know this. That's how you have decided to learn Spring Framework, right? So after learning core Java, Spring Framework is what you have decided to learn. So here we are going to make use of the concept of an interface to solve this left hand side problem. How we are going to solve? Let's check that out. Because there's a very famous object oriented principle known with the name dependency inversion. I don't know if you have heard about this principle before or not, but this principle is so important in object oriented programming world that if you don't know about this principle, then actually you are missing something in your Java project, in your C++ project, whichever object-oriented programming language you use to develop object-oriented programming softwares. Well, you must be missing something out there. This principle was given to us by a great computer scientist, Martin. Some people know him by the name of Uncle Bob also. Now, this principle is not something very difficult. It's actually very, very simple, extremely simple. what you need to do is you just need to understand it. Now, that's a different question whether you are applying this principle in your softwares or not. But if you don't have knowledge about this, then that actually is a bit of problem. Now, let's try to understand what exactly is it all about. And you would realize once we are able to understand this principle, we would eventually be able to solve this left-hand side problem with the help of an interface. So solving this problem with the help of an interface is equal to saying that you are learning dependency inversion principle today. And as I said, this is one of the most important revolutionary principle which was given to us by Uncle Bob, Martin. Let's try to understand this principle with the help of same restaurant and tea class example. So after we have solved the right hand side problem, now the restaurant class actually looks like this. Now I want Sandeep to actually develop this class for me, and I want Geeta to develop tea class for me, just like this. And here, as I was pointing earlier, still restaurant class is depending on tea class. Now this is not something I am saying. This is something which Martin also tried figuring out when he was writing all those object-oriented principles. He said, if your class is depending on any other class, means if you are writing any other class in your class the way we have written over here, then that is a problem. Don't do that. What he said, he actually gave 2 points in dependency inversion principle. First point, what he talked about was restaurant class should never depend upon tea class, means restaurant class should not contain the word tea inside it. In general, whichever class depends on any other class, that is known as a higher level class. And whichever class on which that higher level class depends on, that class in general is known as lower level class. And what this principle talked about, this principle says higher level classes should not depend on lower level classes in any circumstance. That should never happen. Higher level classes should never depend on lower level classes. The way we have written is absolutely wrong. This I'm not saying. Uncle Bob, Martin is saying. So what's the solution for this? What should we do so as to avoid making softwares where higher level classes are depending on lower level classes? Well, this principle also provides the solution for that. And what solution it has provided? It says instead of this, both high level and lower level classes should depend on something called as abstraction. Now what is this all about? High level, lower level, abstraction. Ankush, what's this, what you're talking about? Well guys, this is kind of very easy concept. All I want from you is keep observing and keep going along with me. And you will realize it's actually very simple. It's just a matter of time. In just 5 or 10 minutes, you'll be able to understand this fully. Just keep going along with me. So what it says, high level class should not depend on a lower level class. The way we have written is absolutely wrong. It says that both high level classes and lower level classes should depend on abstraction. Now, what does abstraction means? Abstraction means interface. That's all about it. So you use an interface to solve this problem. That's what I said here, right? I said we are going to solve this left-hand side problem with the help of an interface. So this is something I didn't, I was not only saying. This is something what the great computer scientist Martin gave in 90s. He said use an interface to solve this problem. Now, how we could actually solve this problem with the help of an interface, let's try to understand. So before, actually, I as a project manager would call Sandeep and Geeta to, come up with restaurant class and tea class this way. I would actually write an interface, a simple interface, and I would provide that interface to Geeta, and same interface I would provide to Sandeep. That's all about it. This is all I need to do. And you would realize if I could do so, then actually Sandeep could start writing this restaurant class from the day one itself. He doesn't need to use T word inside it. How? Let's try to understand. So what kind of an interface I would be ready with before I would call upon Sandeep and Geeta to start working on restaurant and T class? Well, this is the kind of interface I would like to write. Public interface I hot beverage. And inside it, I would specify only one function. Public void prepare tea. That's all about it, guys. I'm done. So as a project manager, as the owner of the entire project, I would write this interface, and then what I would do, I would call Sandeep and I would say, hey Sandeep, you just need to come up with the restaurant class which should make use of this interface inside it to make a call to prepare tea function of it. So what Sandeep would do actually, Sandeep is actually not exposed to this word tea. Sandeep doesn't know if Geeta is going to write tea class somewhere. Sandeep doesn't know at all because that's the only information I provided to him. I said, Sandeep, you have to write a restaurant class which is going to consume iHot beverage interface to make a call to prepare tea function of it. Now, who has written this function? Which class object prepare tea function would be called? That's something Sandeep doesn't know at all. So what Sandeep would do, he would actually write here iHot beverage. So instead of this T word, Sandeep is supposed to use this iHot beverage. And that's all about it, guys. So here, using iHot beverage, actually, with the help of iHot beverage interface, Sandeep doesn't need to make use of T word inside his class, this T word. And then after Sandeep has gone to his cabin to start working on restaurant class, I would call upon Geeta again to my cabin and I would tell her, hey Geeta, you would need to come up with the T class which has to implement this iHot beverage interface. So what Geeta would do, she would go to her cabin, she would write a T class, but then she has to implement this iHot beverage interface. In her class. Now, what does it mean that she is implementing iHot beverage? It means that whatever unimplemented methods, we have, whatever methods we have which we haven't yet implemented, those methods Geeta needs to implement in the T class. So here there's only one function, prepare tea, so that's what Geeta needs to implement. Now look at the kind of management I have performed here as a project manager. When I gave this iHot beverage interface to Geeta, now Geeta is bound to actually implement this. She cannot choose any other name for this function. She cannot write like prepare T1 or prepare T2. She cannot change this return type of the function. She has to do whatever I want her to do. She doesn't have any choice of her own while choosing the signature of the method what she's supposed to write inside T class. Now this is again a good thing. So after 15 days when Geeta would come up with T class, I would definitely not have any kind of complaint with the kind of work Geeta has performed for me, because whatever method she has included, I actually provided, that method signature also to Geeta. So I don't have any complaints with regard to whatever signature of method Geeta has used inside the T class. See the advantage of the interface? This is so good. So now I know when Geeta is going to come up with the T class, the only thing which is in her hands is what she's supposed to write inside that prepare T body. Now that's something responsibility of the developer. I don't have any control over it. If she would write the right content, I would appreciate her. And if she would not write the right content, maybe I would tell her to write something else or to make some changes up there. But as far as the method signature is concerned, I wouldn't have any kind of problem with Geeta, because I had communicated what I want her to implement, with the help of this interface, I hot beverage. So now look at the thing, how this overall concept is going to work after I provided I hot beverage to Geeta and Sandeep. Now Sandeep doesn't need to wait for T class to be provided to him. What he can do, he can actually make use of I hot beverage inside restaurant, and he knows that there's a method preparity there. So he just needs to write a piece of code like this. And Geeta would also start working on the T class. She would also implement this method preparity inside it. So after 15 days, when both would come, what I would do? I would write XML file where I would specify a restaurant word, and inside that I would specify T, whatever Geeta has written. So what's going to happen at runtime, when this restaurant object we would create in test class and we would make a call to its preparative function, automatically before that test class would create the restaurant object, this Spring XML file would come into the picture. It would automatically detect that you are trying to create an object of restaurant, and if anywhere restaurant object has to be created, then it's Spring Framework's responsibility to create an object of T class automatically and assign the same to this T reference. So what's going to happen when this preparative function of a restaurant object would be called? This is going to be executed, and now this T reference would have the object of T class, all because of Spring Framework. So that's going to make a call to preparative function. This would get called and everything would happen in the right way. But with this approach, guys, just see, with the help of dependency inversion principle, with the help of the concept of abstraction, interface, we have completely eliminated the T word from restaurant class. And then with the help of Spring Framework, we have again, made the right step not to create T object over here. We haven't done that. So using Spring Framework and the principal dependency inversion, we have actually completely eliminated T word from restaurant. So this is kind of great work what we have done over here. So with this kind of approach, when we make use of an interface and we make use of a framework like Spring, we would make all our team members to work in parallel without waiting for each other's work to be done first. All can start immediately, and once everyone's work is done, then we can actually combine everyone's work so as to deliver the complete project. Now whatever solution I have provided over here with the help of an interface and with the help of Spring Framework for restaurant class, I would request you to apply the same solution for this test class also, so that Ajit would also need not to wait for Sandeep's restaurant class to be provided to him. Ajit could actually start working on test class immediately after I would distribute the work. So once all these classes would be provided to me, after 15 days, because everyone is working independently without waiting for each other's work to be done. So at the max, 15 days is what my team members would take this way to come up with these classes. Once they provide these classes to me, I can actually specify things in Spring's XML file, and then I could actually run the complete project and I could deliver the project to all of my clients. So with the help of two concepts, Spring and dependency inversion principle, we have made our team members to work in parallel to each other. Now there's no need for my team members to work in a sequential manner. So using Spring and Dep, we have achieved parallelism and we have avoided sequential work. Now here, just try to understand that with the help of these two concepts, we have taken out the problem, sequential problem for these three classes. When you are going to work in actual project where hundreds of developers are working, where they are supposed to be working on thousands of classes, where one class is depending on another is depending on some other class, how much useful would be these two things? So useful, isn't it? That's why Spring Framework is so famous, guys. That's why dependency inversion principle is so famous everywhere. That's the reason almost every company, developer, professional, student is kind of mad for this framework. They actually want to use this framework just because of the approach what this framework, uh, provides to the developers, and the kind of good things come with dependency inversion principle. Now, here, one last concept I would like to talk about related to dependency inversion principle. What here it says is high level class should not depend on lower level class, and that problem we can solve using the abstraction concept. Means that problem we can solve with the help of an interface, and we solved it, no issues. But there's one more point this principle talks about actually, and that's actually the most important principle, and that's actually the reason why the name has been given like this, dependency inversion. Now what that principle is, try to be very carefully understanding this point. So this principle, this second point of the principle talks about whenever you are using abstraction, an interface to avoid this high level class dependency on lower level class, that time always make sure abstraction is written first and then its implementation. Now what do I mean by that? Well, here the kind of management I have performed for this restaurant management system, I have performed things in the right manner. What I did, I wrote an interface first, I hot beverage, I provided that to Geeta, and then Geeta started working on T class with the help of whatever I gave to her in the I hot beverage. But you know what? Whatever I followed here, that's something not being followed in the industry, guys. Try to understand this point. I followed the right approach, but in industry, in general, people do not follow this. What basically they do, the developer who is actually writing the class, actually same developer is supposed to write the interface also. And what he does or she does, they come up with the T class first, and then they include all the required methods in the T class, and then looking at what kind of methods they have included in T class, what kind of signatures and nomenclature they have used for the methods inside T class, they would then write I hot beverage interface. Have you understood the problem? So the problem is people would actually write the implementation first, means they would come up with T class first, and then looking at the T class, they would actually write I hot beverage. So in other words, they are implementing I hot beverage in T, but that's just for the heck of formality. So what they would do, they would write T class first, and then they would come up with I hot beverage, and then they would simply add this implement I hot beverage line after T, and they would provide this class to their managers or leads or the team members, and they would say that, hey, we have come with the T class implementing I hot beverage, we have followed the best practices. But here it's not, they haven't followed the best practices. What they have done is they have written T first and then they have written I hot beverage. Instead of that, if they could write I hot beverage interface first and then write T, that's what the second point talks about. The advantage of writing I hot beverage first and then T is something that you can understand by understanding how people construct buildings. Have you ever seen developers, all those building contractors, they would develop the entire building, and then looking at what they have done over there, they would come up with the maps, or they would come up with the entire sheet of how the building has been constructed. So what basically architects follow, they first architect the entire building. They write down on the piece of paper what they actually have to build, And then looking at that piece of paper, they actually construct the entire building, right? So first constructing the building and then writing the architecture of that building on a piece of paper is actually the wrong approach. What a person can get out of such an approach? Well, same is the concept over here. iHot beverage is just like this architecture of the building. So once iHot beverage interface is ready, it's only then you have to construct the building. You have to build the T class. That way it is going to be helpful. But because developers, most of the times, I would say almost, they prefer the approach where they write implementation first and then looking at that they come up with the abstraction interface. That approach is definitely not good, and that's what is the second point of this DIP principle. Abstraction has to be written first and then all its implementations should be written second, means after that. Now here, because this second point challenge all the developers who actually write implementation first and then they write abstraction second, right? This principle challenge the normal practice what has been followed by almost all developers. Yeah. So here this principle is actually challenging the normal habit of developers. So this principle actually is doing inverting. This principle is actually inverting the normal flow of what people follow in the industry. That's the reason its name is dependency inversion principle. Dependency inversion principle. It's actually inverting the kind of behavior. It's kind of suggesting that you have to invert the kind of behavior what developers follow while writing their piece of software. That's the reason its name is dependency inversion principle. All because of the second point. So here what you have to take at home from this DIP principle: high level class should not depend on lower level class, and that problem you can solve with the help of an interface for sure, but you have to make sure that interface has to be written first and then T class, then all its implementations. Now here in this session I kept on saying that I'm the project manager, I have to give this interface to all my team members, I need to manage. Well, here when I say I'm the project manager, I could be any of the team members. I could be any one of my team members. The guy who is supposed to write interface has to be the knowledgeable guy. He should not be any XYZ guy within the team who doesn't know anything about the project. Can you see this iHot beverage now is being used inside restaurant, is being used inside tea, and is going to be used in many other classes of my project. Now restaurant class is actually not depending on tea, but it's actually depending on iHot beverage. Tea class is actually depending on iHot beverage. Many other classes inside this project would depend on iHot beverage. Now just imagine if there's a slight mistake, what that developer is going to commit while writing this interface. That's going to cost a lot, guys. If developers would find a slight mistake in this interface and they would correct that later on, then every class which is depending on this would need to change. So make sure that this interface, that person only writes who has the knowledge, who has the complete vision of what this project is all about, how things would look like after 5 or 6 months down the line, when you are carrying out with the development tasks for that project, how things would look like after 2 years or 3 years. So that guy has to be a knowledgeable guy. That guy has to be the person who knows object-oriented software. That guy should know the requirement of the overall project. That guy has to be the master. Okay? And definitely masters come from the crowd only. You, if not are the master, tomorrow you may become the master. Only thing is your courage is needed. Whenever you're writing an interface or any such aspects in your software, make sure that you give your best while designing the interfaces, while designing your entire object-oriented software, so that you also become the master after a while. Okay, so here with the help of Spring Framework and the dependency inversion principle, we solved this entire problem. And the way I've done for restaurant, same thing you have to do for test class and solve this. And that's all about it, guys. Now in the next session, what we are going to talk about is whatever theoretically we have tried understanding today, restaurant class, tea class, test class, problems, and then solution, all these kind of problems, whatever we looked at today, what kind of step-by-step solution what we looked at today, we are going to talk about these things practically in the next session of Spring Framework, where I'm going to show how to actually build this principle, how to actually build this project with the help of Spring Framework and using the design principle dependency inversion practically. Okay, so thank you very much for joining me today. Let's catch up in the next session.